Welcome back to my science lessons. Hooray! Today we're going to continue with using the microscope. So we identified the parts and now we're actually going to use the microscope. So we're going to concentrate on what happens when you look at images in the microscope and move them around and try to focus on them and all that good stuff. So this is Microscope Images. And we'll do that, and then maybe we'll get started with looking at actual real live moving squiggly little things. Although my son is very talented at holding a phone into an eyepiece, as talented as he is, it's not going to work very well for us, especially when we start looking at things that are moving around. So I have a backup. I have this fancy microscope. One of my students' parents bought this for me a couple years ago, and the cool thing about it, not only that it's binocular, it has two eyepieces to look through, so I don't strain doing this all the time, is that it also has a camera, so that I can, whatever I'm looking at in this microscope, I can put it into my computer and record it, and then you can see what I'm seeing. So this is what I'm going to be using when we do a lot of this. I'm going to do a couple of things because I'm going to have my son look at some stuff and describe it just for a couple of little things. Okay, so most of this, when you see it, you're going to be seeing it through this one. It's got a higher power of magnification, which we will get into. It's a little bit different. You can see that it has 4 objective lenses. Has this fancy thing so I can move the stage back and forth, side to side, when we're looking at things, so that I don't have to move the slide around back and forth and stuff. So anyway, a little more fancy. This one works well enough though. Good? All right, so this is looking through the microscope with my son's amazing camera work by putting the phone up to the eyepiece. Now what you see, there's like a line in there, that's a pointer so that you can move the slide around, so whatever you're looking at, you can put at the end of that pointer so people know what to look for. And what I'm gonna do is adjust the mirror. So here I moved the mirror so that the light's really not coming in very much, and now it's coming in a lot. So that's just with the mirror, okay? Now, the diaphragm, once that, I don't know if this is gonna work very well, but if I move the diaphragm, you can see there's less light coming in as I move the diaphragm and more light coming in, just depending on the size of the hole. Okay?
It's really
that's hard to do, isn't it?
Yeah.
Yeah. When you're going to look at something in the microscope and you have your slide, I want you to notice something. Can you tell what that is? Yes? What is it?
An E.
An E. It's the letter E. So when I put this onto the stage, first of all, you want to make sure the stage is all the way down and the smallest objective lens is over the hole, and you have light coming in through, I gotta get light. Okay. When I put this on here, you can still see the E, right? And I put it over the hole where there's light coming in. Got that? Okay. Now, if I don't do anything except find the E, I want you to notice something. So I'm gonna let you try to do this with the phone. Can you try to look through the eyepiece? What do you see?
Ink. Letter E.
The letter E, and what about the letter E? What's weird about it?
It's backwards and upside down.
Yeah. So that's what happens when you look into the microscope. It flips the image, okay? Now, I don't know if we can do this. If you do this one more time, and I'm going to move the slide away from me. So I'm going to move it that way, and I want you to see what happens to the image. Okay? Got it? I'm going to move the E. Oh, I moved it away from me. Where did it move to you?
To the bottom.
Yeah. So I moved it I moved it away and it moved toward us, right? I'm going to move it to the right. Where did it go?
To the left.
Yeah, so it goes opposite. All right, that's what I wanted you to see when you're looking at an image in the microscope. It flips it, and this is what makes it difficult, because if you see something that's wiggling away from you, You don't want to try to follow it by moving the slide that way. You want to go the opposite direction. So if you find a little organism and you're trying to follow it, you actually have to move the slide the opposite direction. It makes it really, really hard to do. So that's the first thing you want to do. So on the sheet, the microscopic images sheet that you're supposed to be filling in, that's what we're going to be filling in about the E. Okay? Supposed to be putting in an answer for number 2. We moved the slide away from us, and direction it moved toward me, right? And so that's kind of what it looked like as I moved it away from me, the image moved toward me. Okay, and then for 3, the slide, we moved it to the right, it moved to the left, right? And so I drew it there, what it looked like. The next thing we're going to do is look at a color photograph. This is a picture that I cut out of a magazine. It's nice and colorful, and I'm using my fancy microscope for this. This is what the picture looks like normally, and then we're going to look at it using the microscope. This is looking through the microscope at a magnification of 40. So it's on the shortest objective lens, and you can see now it looks a lot different than just colors that you saw when you were looking at it without the microscope. You can see actual fibers from the paper, and the colors are more like dots. And when they mix together to our eyes, when we're not looking so close, it looks like smooth colors. That's pretty cool. Now we're going to look at some feathers. So this is kind of a orangish red feather that we're going to look at. So this is what it looks like normally. And this is what it looks like when we have it in the microscope. You can see that there's lots of layers to it. It's hard to focus on just one part. Now we're going to look at a much fluffier kind of feather. You'll notice with this one, there's a lot more layers that you have to go through. So it's hard to focus on just one particular part because of the fluffiness of it. You have to go through all the different planes. Those are called focal planes. One more feather. This one is so fluffy that we're going to have to do something different with it. For this one, we're going to squish part of it between 2 microscope slides to hold it down. Even while it's pressed together between 2 microscope slides, it's still pretty impressive to see how many layers of this there are. So the focal plane, even though it's squished, each time you move the adjustment knob, it focuses in on a different part. In your own words, what is magnification? I'm going to let you do that one. The other part that I want to make sure you understand is with the microscope, this part right here, remember the eyepiece? We said it was a power of magnification as 10, but each objective lens also has a power of magnification. So the first one, the smallest one, is 4 times. The objective lens is 4 times. The eyepiece is 10. So when we're looking through the eyepiece using the smallest objective lens, our total power of magnification, we're seeing it 40 times. You're multiplying 40 times larger than what the thing actually is. Here's what a 12-point font letter E looks like magnified 40 times. Okay. The second objective lens is a 10. The eyepiece is still 10. So we're seeing it at 100 times larger than it really is. And here's what it looks like in the microscope. The letter E magnified 100 times larger than it really is. You'll notice that you can't see the whole E anymore. And then the last one is 40. The lens magnifies it 40 times, but your eyepiece magnifies it 10 times, meaning you're seeing it 400 times larger than it really is. Believe it or not, that is the letter E magnified 400 times its regular size. You can see how the little tiny bits of ink are embedded into the fibers of the paper. And this is what's frustrating because the field of view becomes so small that if you were trying to focus it on the middle part where the E, where there's no ink, you wouldn't see anything at all. And so it can get really frustrating when you try to look at something magnified that much. Okay, so for example, now if we are looking at the microscope, and this is not to scale at all, but that gives you a better idea of how this works. The field of view is how much you can see. So at the first one, 40 times, you're seeing the E 40 times bigger than it was. So this will work better if I show it to you in color. The very outer circle, the biggest circle, includes the two smaller ones. The outer circle is what you would see of that E if it was at 40 times magnification. So the eyepiece is 10, multiply that by the objective lens that is 4, and that is what you would see. So it includes the blue, the green, and the pink. You would see the entire thing at 40 times magnification. When you turn the objective lens to the next highest one, it's 10 times magnification, and you multiply that by the 10 times of the eyepiece, you would then move into that next circle. So the one that's not the smallest one, but the medium one, and you would see the part in green and pink. You would see all of those, but you wouldn't be able to see any of the blue if you magnified the image to 100 times its normal size. And then finally, if you turn your objective lens to the longest one, that has a power of magnification of 40, and multiply that by the eyepiece of 10, you have a total power of magnification of 400 times the normal size. That's the very center circle. You might just be seeing the very edge of the letter E, so you might see a little bit of black ink. You might be in the very, very center where there's nothing. And so you're just trying to focus and find something, and all you see is white paper. Or you might be on that whole green part taking up the entire focal plane, meaning that you're just going to see a big black blob. So it really depends on where you end up, and it's hard to tell where you are when you're looking at it. So the total power of magnification of 400 is one that's really difficult to do, and you could do it with practice. And if we were in class, you would certainly be spending some time on that. So we're going to talk about focal plane one more time. So if you remember with the fluffy feather, it was hard to focus on just one thing because you had to go through the layers. We're going to demonstrate this with these 3 pieces of ribbon and trying to focus on those as we stack them up. We'll start with just one piece of ribbon on the microscope slide. That's the purple one. Let's see how nice and clear we can make that. Now we will add the yellow on top of the purple. So when we try to focus it, you can see the purple come into focus and then the yellow. But notice we can't focus on both of them at the same time. So now we'll put the red on the top layer. And now you can see we focus first. We'll find the bottom is purple. That comes into view. And then that will get blurry as we focus and keep pulling back to see the yellow nice and clear. And then finally, we'll focus on the top layer, the red. Oh, hey, I didn't see you there. So this is my lab, my kitchen, and I just wanted to show you this is my fancy schmancy microscope that has this cool camera on it so that I can look at the computer and see what I'm finding. Tune in next time for more. What are those things? Gross.